I just want to focus here on the possibility for ingredient producing for reducing the blood glucose response via using different kind of ingredients. So when you are looking at the carbohydrate quality, you can modify the carbohydrate type and the physiological properties. So meaning that you, on the one hand side, can modify the glucose supply, so reducing the blood glucose response of the available carbohydrates in a food. Options that are available, as we heard from Christine and also from Nathan, are processing techniques focusing on starch, is by using viscous soluble fiber, and also by using novel low glycemic carbohydrate ingredients. And here I will address the example of Palatinose, which my company has in their portfolio. When we are looking at another way to address the carbohydrate quality, so we can reduce the glucose supply by replacing available carbohydrates by either partially or non-available carbohydrates. Options for this are, for instance, the replacement of sugars and starches by dietary fibers, so for instance, inulin and oligofructose. Palatinose, as we already heard, is a slowly digestible, low glycemic carbohydrate, and when we are looking at the small carbohydrate, at the sugar, so it's so far the only one which is characterized and approved to be used in food as a disaccharide and low glycemic ingredient. So it's produced from sugar beet-derived sugar with an enzymatic rearrangement. We have a different linkage between the glucose and fructose molecule, leading to a more slow and sustained digestion in the small intestine, and correspondingly to a lower blood glucose and lower insulin response. This has been meanwhile confirmed in more than 30 studies. What we as a company are now interested is to look beyond the blood glucose and insulin response. And one of the key topics which have been come up in recent years is to look at the effects on the incretin levels. So incretins are a special group of gastrointestinal hormones that stimulate glucose-dependent insulin. One of the first examples was a study from Maeda, who looked in a typical glycemic response design with 50 grams of Palatinose at the blood glucose response together with the incretin response to Palatinose compared to sucrose. Interestingly, they found that with the Palatinose intervention, you have a much lower CHIP response with Palatinose, whereas with respect to the GLP-1 response, you see a much higher and more prolonged GLP-1 response with Palatinose when you compare it at an equal carbohydrate level to sucrose. So from this study, the authors concluded that in addition to the lower blood glucose and insulin response, you see a lower CHIP response, and CHIP is released from the K cells in the upper GI tract, and you have a higher GLP-1 response, which is released from the L cells in the lower GI tract. So based on these two observations, it could also pinpoint into the direction that Palatinose as a disaccharide is more distally enzymatically hydrolyzed compared to sucrose, and thus provides a more sustained release of carbohydrates compared to more rapidly available sucrose. A second study looking at the similar direction is coming from the group of Ang and Linn. So this was a study in type 2 diabetes. In this study, they combined a euglycemic hyperinsulinemic clamp with the double stable isotope labeled isomaltulose or sucrose load. They analyzed postprandial kinetics over 4 hours and looked at hormonal responses, insulin, C-peptide, glucagon, CHIP, and GLP-1. From the glucose kinetics, they found a prolonged intestinal absorption of isomaltulose by more than 15 minutes when you compare it to sucrose. They further found a suppressed endogenous glucose production with isomaltulose and an overall 35 lower systemic glucose appearance when you compare it to sucrose, which was related to the higher first-pass planching glucose uptake observed in the Palatinose intervention. And they also could observe that the insulin action was enhanced after the isomaltulose compared to sucrose. So the key findings from this study is not only confirming the low glycemic insulin properties of isomaltulose in type 2 diabetes, so they confirm the incretin response, the lower incretin response with respect to CHIP and the higher GLP-1 level, so confirm the study of Maeda. And this study nicely provides additional data to blood glucose measurements on the glucose flux after isomaltulose ingestion in humans based on stable isotope measurements. So confirming the prolonged intestinal absorption of isomaltulose, a suppressed endogenous glucose production, and a lower rate of glucose appearance in the circulation. So overall, the authors concluded that the slowly available isomaltulose improved overall postprandial glucose flux compared with the ingestion of rapidly absorbed glucose. This is another publication looking at the incretin hormone response coming from the group of Andreas Pfeiffer. And this is an experimental study in mice. They examined, on the one hand side, the short-term effect, so an acute intake of sucrose or palatinose containing diets, and on the other hand, they were interested in a long-term effects and looked at wild-type mice and mice which had a knockout for the CHIP receptor and that consumed a high-fat diet with sucrose or palatinose over a period of 22 weeks. From these experiments, they confirmed the lower postprandial CHIP response with palatinose. They found an improved glucose tolerance over the long-term intake of palatinose, and they also could find a reduced hepatic lipid content and liver damage after long-term intake of palatinose. What they were interested is to investigate if there is a link between the hormonal incretin hormone response regulation and the liver fat content, and that was actually nicely confirmed by this experimental model of a CHIP receptor knockout mice. So these mice behaved similarly to wild-type mice that were fed palatinose, showing a lower hepatic lipid accumulation and a better glucose tolerance. And the overall conclusion from this experimental study was that palatinose prevents the development of non-alcoholic steatohepatitis and impaired glucose tolerance independent of obesity and by lowering the postprandial CHIP response. So again, pinpointing to the key mechanistic effects of CHIP and GLP-1 responses. These are the data I just wanted to summarize for Palatinose, the most recent data, when we are looking at the sugar starches replacement by dietary fiber with inulin and oligofructose. Inulin type fructan, they are plant extract, not chemically synthesized, so they are extracted by hot water extraction from chicory roots. When inulin is partially hydrolyzed by enzymatic means, you result in the shorter chain inulin, or also called oligofructose. And yes, with as you can see here from this excerpt of the EFSA journal, we were together with other inulin producers, one of the few who were lucky to achieve a positive scientific opinion for a reduction of postprandial glycemic response claim based on particular studies we did. This study was not really high rocket science, so it looked at the sugar replacement effect or the sugar replacement with oligofructose, inulin. So, and if you replace this amount of glycemic sugars, then you get a lower blood glucose response in a food product. But there's much more than this fiber in, sugar out replacement effect when it comes to blood glucose reduction. And this has been summarized in a recent systematic review and meta-analysis by an Australian research group of Kello and Christopher Reed. So they could show in this meta-analysis a significantly reduced postprandial glucose and insulin concentrations for a more continuous intake of prebiotic fibers. We also heard in the talk of Professor Riccardi that the fermentation of dietary fibers might also be of key importance for the benefits with respect to glycemia and metabolic benefits. And this is another example from a French group published in Cell last year, who could show that oligofructose and short-chain fatty acids increase glucose tolerance, insulin sensitivity, and reduced weight gain. And they attributed this to the effects by short-chain fatty acid. So they pinpointed to the effects of propionate, which is of importance according to their results for gut-brain neural communication. And they also addressed butyrate, which might activate intestinal gluconeogenesis through impacts on cyclic AMP. Yes, so this is a short update on additional ingredients for reducing the glycemic response of foods. So I think that reducing the glycemic impact of the diet is a valid nutritional objective, considering the increasing prevalence of diabetes, overweight, and related carbohydrate and lipid metabolism disorder. And when we are looking at the manufacturing of foods, so an increased availability of foods with a low or reduced glycemic properties will eventually benefit the consumer and his options for healthy food choices. We also are aware that the food industry has many options available. Jenny Brent-Miller already addressed the issue of breeding options, but the other and I think more applicable option to modify the glycemic response of certain food products is certainly to the use of alternative carbohydrate ingredients that have a lower glycemic response than the conventional forms. And with that, I thank you for your attention.
Thank you for your presentation. I just wanted to know what the relative sweetness of Palatinose was to sucrose, whether it actually provides kilojoules, and are there any adverse gastrointestinal consequences of consumption?
Palatinose is a completely digestible carbohydrate. We have done ileostomy studies showing that it is really completely digested until the end of the small intestine. And you have asked for the sweetness. If you compare it on an equal concentration to sucrose, it's about 50% as sweet. 50. 50. It's as it is a completely available and digestible carbohydrate, it has the same caloric content as sucrose or other available carbohydrates. So 4 kilocalories per gram.
Yep. Thank you.
Thank you. Very interesting. What sugars does Palatinose break down to?
Pardon?
What sugars does Palatinose break down to? Sucrose, fructose, and glucose.
Yes.
Maltose.
Palatinose is an isomer of sucrose. So it's consisting of one molecule of glucose and one molecule of fructose. But in contrast to sucrose, where those two monosaccharides are linked by an alpha-1,2 bond, this is now linked with an alpha-1,6 bond, which is more slowly hydrolyzed by your intestinal disaccharide-ase. But the same enzyme, so it's sucrase, isomaltase, the same enzyme which are responsible for the cleavage of sucrose, maltose, isomaltose.
You produce isomaltose by taking sucrose and isomerizing it, correct?
Yeah.
Is it possible that there is a sugar cane out there that naturally produces isomaltose?
I know that in particular in Australia there were some research efforts in this direction. So far I haven't heard that they were successful, because I think the difficulty is to produce really isomaltulose in a sufficient content that it is still possible to extract it and to use it as an alternative to sucrose.
I couldn't think of any single step that might improve human health more than replacement of sucrose with isomaltulose, assuming that there are no symptomologies, that you have this higher GLP response and lower glucose and insulin response as well. But at the moment, is it not true that it's very, very expensive?
It depends on how you see it. If you really look at the additional costs per portion of food, if food companies would use it, we are in the very low cent range. Yeah, so let's say 2 or 3 cents more or whatever. But even this low additional costs are for many or some food companies even too much to use Palatinose on a wide range in their products.
Right. No, wanted to make a clarification. I mean, the claim you show in the screen is not really about inulin or GOS or FOS. It's about replacing digestible carbohydrates by non-digestible carbohydrates. So it's a very wide claim. Anybody can use, meeting the conditions of use.
Yes.
So, yeah,
No,
I wanted to make that clear.
No, that's in fact the case. We have submitted this application, which was specific for oligofructose. What EFSA has at the end made out of this is a general opinion related to non-digestible carbohydrates. And what is probably now part of the legislation is that it is very broad for all dietary fibers. Yeah, so we have invested together with other inulin producers quite some money in new studies, in filing this dossier, and writing this dossier, and submitting this dossier. And what we at the end get out is absolutely no competitive advantage to other companies. So that's it.
But the reason for that is, and I want to explain because it's a situation we had with other claims on carbohydrates. For example, in relation to dental health, etc., fermentable versus non-fermentable carbohydrates. So the request we got from the Commission is, if possible, to have general claims. In this case, was a very clear case because the scientific principle could be applied to any digestible carbohydrates when being replaced by non-digestible carbohydrates. So it is perceived also from the legislator as a competitive unfairness. See what I mean?
I fully understand the point you mentioned from the Commission or from EFSA, but maybe you also understand our thinking or my thinking as a company which is heavily engaging in research and science and really investing a lot of money. And at the end, this investment in new research is not taken into account, but to a certain part taken into account, but the commercial advantage that we could get out of such an investment is definitely not there.
I'd like to just say, yeah, Stephan, it was the same for resistant starch when we submitted for high amylose maize, but EFSA said it's for all resistant starches, and it is fair, but we did invest all the time, but really there's no answer here. It's just in terms of the public benefit, it is good that it can be applied to other ingredients, and there'll be more products to use the claim. But it does stifle innovation in the food industry when these trials can cost $500,000, and then you don't really get a competitive advantage from it. So it's difficult for the food industry to innovate in health because of the investment. We're not the NIH, so it's...
It was not trying to make any EFSA's point because it's not really our point. This is what we are requested to do.
Right, well, absolutely. I agree with you, but
but I see also, that there are other things to be taken into account in the authorization process, for example.